So now we want to look at the following. We want to find the limit of f of x as x approaches 2, where the function f of x is going to be 1 if x is not equal to 2, and 0 if x is equal to 2. So this type of function is a piecewise function, and it has a really nice looking graph. So let's just look at this limit graphically. So when x is not 2, my function is 1. So everywhere except for x equals 2, my function is 1. And then when x is 2, my function is 0. So my graph looks like this. And let's look, again, we don't care what happens at 2, but we need to see what happens as I approach 2 from the left and from the right. So let's approach 2 from the left. What does it look like my function is doing? Well, it's always 1. It's always 1 as I get closer to 2 from the left. And if I look at the right now, as I approach 2 from the right, what are my y values? Well, they're always 1. They're always 1. And so it looks like no matter what, my function is getting closer to 1. So the limit would be 1. So again, when I approach from the left, my function was always 1. When I approach from the right, my function was always 1. And so this limit is 1 here. And again, I don't care what happens at x equals 2. So this point here has nothing to do with the limit at all. Let's look at our next example. What I want us to do is show that the limit as x goes to 0 of the absolute value of x over x does not exist. So again, for this one, we're just going to look at it graphically. Let's graph the function, the absolute value of x over x. Remember that this function is undefined at x equals 0. So if I graph this function, what will my graph look like? Well, your function will be a positive 1 if x is positive, and it will be a negative 1 if x is negative. So we're taking the limit as x goes to 0 here. So let's look at our graph. We're going to approach 0 from the left. So let's see if I approach 0 from the left. All right, let's look at my y values. My function is always negative 1. And now we're going to approach from the right. My function is always 1. So those two things are not the same. So the problem here is that my function, f of x, approaches different numbers from the left and right side of 0. So basically, what this means is that the limit does not exist. Because if we approach on the left and get one number and approach on the right and get a different number, then the limit does not exist. So the limit that we were asked to find does not exist. The two sides have to agree in order for this limit to exist.